Hello, in this video I'm going to look again at the fundamental trigonometric identities, and it's part 2 of the toolbox. I'm going to look at this, looking at deriving this identity and seeing why it is what it is. So let me write it up here. Sine squared theta plus cosine squared theta is equal to 1. So again, what this is saying is that regardless of what angle I put in there, this is going to be a true statement. So first, let me just kind of make the comment that this is usually written here, and what we mean is the square applies to the function as opposed to the angle. So what I mean is we don't mean this. Right? That would be the square applies to the angle. That's not what we mean. Instead, what we mean is we could write it this way, where you really see that it's the entire function after it's been evaluated for the particular angle that gets squared. So essentially the output is getting squared. All right? And that's really what we say, but this is a bit cumbersome to write, so we usually write it this way. Now, what this really comes down to is we could start with the definition of the function of a circle. So if I want to look at the definition of a circle, I would say a circle is the set of all points which are equidistant. Sorry, that's a C. Which are equidistant from a central, I'll put central point. Right? Because when you go to draw a circle, you know, you could do this in the sand, right? Put a stick here, and then if you have a stick here and then you had a string, right? And you just kind of rotate that string around, and it would give you a nice circle, because all these points would be the same distance away from this center point. Okay. Now, since we are talking about distance, you might think about appealing to the distance formula, right? Distance is the square root of x minus a squared plus y minus b squared, where a and b are just the center, right? It's the central point. But I want to go and make this just a little bit simpler. We can center the circle on the origin. So if we do that, right, we would have something like this, right? We would expect the circle to be here. Here's the origin. I can center it anywhere I want. And here's just any general xy point, right? And essentially this distance is the radius. So when we look at this, then, if I look at any right triangle, this point right here basically is over x, right? It's in line with this point, so it's over x, but it's also in line with this point vertically, so it's in line with this point here horizontally, in line with this point here vertically. So I would have x0. That would be the coordinates of this point right here. Well, if you look at that, then what we have is a triangle, right? Where this is xy, this is x0, and this is 0, 0. And if you look then at how do I find this, for example, this length here from here to here, from 0, 0 to x0. Well, they're on the same y, they're in the same vertical position. The only difference is really the horizontal position, so you would really look at x minus 0, which would just be x. So the length of this is x. If you did this here, both points are in line horizontally. They both have the same x coordinate, so they only differ in their y coordinate. So this would be y minus 0, or just y. So essentially, the length of this is y. And I can call this d or r or whatever I want, but I can use the Pythagorean theorem, right? This is a right triangle, and essentially, if I call that the radius, I'd have x squared plus y squared is r squared. There you go. And again, if I wanted to apply the distance, right, I would say x minus 0 squared plus y minus 0 squared, but then I could square both sides and have the r squared, where r is the distance. So again, this is really just the Pythagorean theorem. Now that we have x squared plus y squared equals r squared, let me go ahead and write that down. Maybe start a little bit cleaner. So x squared plus y squared equals r squared represents the set of all points which are equidistant from, in this case, our central point is going to be the origin 0, 0. All right? Now, from here, I want to appeal to the definition of sine and cosine and do a substitution. We know that, let's put this over here to the side, we know that sine of an angle is y over r, and cosine of an angle is x over r by definition. So what I'm going to do is solve for y. So if I do that, I'm going to have y equals r sine theta. And here I'm going to solve for x. X is r cosine theta. And now I'm going to plug these in here. So with the x, I'm going to have r cosine theta, all of that squared, plus here r sine theta, all of that squared, is equal to r squared. So this square is going to apply both to the r and the cosine theta. So I'm going to have r squared, and I'm just going to still write it like this, cosine theta quantity squared. Then r squared times sine theta squared is equal to r squared. Now here, all of them have r squared, so I could just divide through by r squared, or I could say I'm going to multiply by 1 over r squared to both sides, right? So I'll have r squared cosine theta here squared plus r squared sine theta here squared, right, equals 1 over r squared times r squared, right? So obviously 1 over r squared times r squared, that gives me 1. And then here, when I distribute, right, the r squareds will cancel out, and I'll just have cosine of theta squared. And then again, the r squareds here will cancel out. I have the sine of theta squared. And again, if you recall, at the beginning I mentioned that this form is really written this way, where the square applies to the function. So I can write that cosine squared theta plus sine squared theta equals 1. And by the commutative law, right, I can switch the order of addition. Sine squared theta plus cosine squared theta equals 1. All right. So then from here, this is absolutely fundamental, right? You absolutely have to commit that to memory. Now you can go into some of the other forms. Let's see if I have that paper again. So we'll go and see how we get these two forms. And these two forms are very easy to get, but they really occur often, and you want to use them when you're solving equations an awful lot, and of course verifying identities. So let's see how we get that. So if I start with sine squared theta plus cosine squared theta equals 1. Then here, if I just want to, let's say, subtract sine squared theta from both sides of the equation, right? This will cancel out, and I'll get cosine squared theta equals 1 minus sine squared theta, right? And I can also, instead of subtracting sine squared, I could subtract cosine squared, right? So here we got this form right here. Now we're going for the next one. So also, if I start out with sine squared theta plus cosine squared theta equal 1, I can subtract cosine squared theta instead from both sides of the equation. Right? So this will cancel out. I'll be left with sine squared theta equals 1 minus cosine squared theta. Again, very simple rearrangement, but so you just have to see it. That way you don't have to memorize. You kind of know where it comes from, right? And then also, let me just extend this a little further. I'm going to show you identities that a lot of people like to use, and they want to include them in the toolbox, but there's really no need to, because it's just, again, a rearrangement of a different form of this fundamental identity. So here, starting again, sine squared plus cosine squared equal 1, now instead of subtracting, I'm going to divide. So I'm going to, let's say, divide by sine squared. Right? As long as I affect every term, this is absolutely legal. Right? But now here, what do I get? I get 1 cosine squared over sine squared. That's going to be cotangent squared, right? And then 1 over sine squared is cosecant squared. So here's another identity some people use quite a bit, but I don't memorize it because I know I can just get it very quickly. So let's do the same thing, but instead of dividing by sine squared, I'm going to divide by cosine squared and see what comes out. So now I'm going to divide by cosine squared. Okay, so sine over cosine, that's tangent. So this is tangent squared theta plus, again here, 1. And then this is secant squared theta. Okay, so again, no need to memorize. Just start with the fundamental identity and divide by sine squared or cosine squared to get one of the other ones. All right, thank you so much for listening.